is a linkage? So somebody already told that the tendency of two or more genes. So I'm writing here the tendency of two or more genes to stay together during inheritance, or we can say during gametogenesis. Or we can say that linkage is the consequence of the concerned gene being together. So some genes have the tendency to being together. So linked genes will not show. So we can say that linked gene will not show segregation. It means that they will conflict. There will be conflict of the law of segregation of the Mendel in case of linked gene. Now, if we say that in dihybrid cross, what was our ratio? That was 9 is to 3 is to 3 is to 1. And dihybrid back cross, the ratio will be 1 is to 1 is to 1 is to 1. So this is our expected ratio, but due to linkage, this expected ratio will be significantly different due to this linkage. Now I will tell you two conditions will be there. Suppose this is our one parent, capital A, capital B, and if we cross small a, small b, similarly capital A, capital A, small a, small a. Now if I denote this like A, B, this is loci. Somebody asked that this is our chromosome, and on that chromosome genes are there, and this is loci, and this is like this setup. Now after crossing, we will get a gamete, or we will get a different gametes will be there, and the offspring, that is f1 will be capital A, small a, capital B, small b. So this will be, and this will be like A, B, and small a, small b. So this is known as coupling phase. This is known as coupling phase, means dominant is with dominant and recessives are with recessive. So these are in coupling phase. If now same here, if this loci are like this, sorry, capital A, small b, and now this is the setup. Okay, so I will get f1 like capital A, capital B, small b, same f1. But here the situation will be capital A, small b, and small a, capital B. Okay, so this is known as repulsion phase. So this is two phase are important, coupling as well as repulsion. We will see in later on classes that how these two phases are important. Now, what will be the gametes here? What will be the gametes here? This will be capital A, capital B, capital A, small a, capital B, small a, small b. Okay. Similarly, gametes will be here capital A, capital B, capital A, small a, capital B, small a, small b. But why I am writing the same again? Because there is difference. See, this is parental type. This is also a parental type. Okay. See, because in this is our parent. Now the gametes will be here AB and small a. But here the gametes will be capital A, small b, and small a, capital B. Okay, so this both are parental type, and this is called as recombinant type, because we are getting two new gametes, that is called as recombinant type. But here in repulsion phase, this is parental type. See, capital A, small b, and small a, capital B. So these two are parental type, but these two are recombinant. Okay, so this is the difference in coupling phase, in repulsion phase. We will get different, we will get here two parental type and two recombinant type. In just opposite here, that capital A, capital B, and small b will be recombinant type, and this is parental type. Okay, so from above we can say that we come to know that recombinant type in coupling phase, we can say that recombinant type in coupling phase is the parental type in repulsion phase. Okay, and we can say and vice versa. Now coupling phase is after cell division, two or more dominant genes remain together. So I told you that two genes will remain together, two dominant genes will remain together. That is coupling phase. And after cell division, recessive genes remain together. So in this recessive genes remains together, then it is known as repulsion phase. Did you get this? Coupling as well as repulsion. Any doubt in this?
Yes, sir.
Okay. So now there are two type of linkage. Two types of linkage are there. One is complete linkage, and one is incomplete linkage. So complete linkage, incomplete linkage, only parental type offspring we will get, of parental type gametes we will get. But in incomplete linkage, recombinant type will also be there. What is the meaning that only parental type will be get? So if suppose if there is complete linkage, so this type of gametes will not be there. Only means it means that these two, suppose I am writing again this. So during we can say cell division during cell division, the crossing over will not be present. Crossing over is what? The changing of uh, changing of this loci, or we can say changing of that genes in the chromosome. So this will not happen in complete linkage. It means these two genes or these two loci are having linked together. There will be a tight linkage, so they are not separating, they are not segregating. So that's why we will get only parental type in complete linkage, and in incomplete linkage we will get recombinant type also. Okay.
Repeat, sir.
What?
Once more, sir. Just repeat, sir.
Okay. So in case there are two type of linkage, that is complete linkage. So incomplete linkage, only parental type of gametes will be there, because see this, suppose this is my loci and this is chromosome and these are loci and A and B are loci are there. So there will be complete linkage. So they will not, they have tendency to link together tightly. They will not go from, means they will not separate from each other. So that's why we will get capital A capital B. We will not get this type. We will not get capital A small b type. Only we will get parental type of gametes. So this there will be a complete linkage. Okay. And in incomplete linkage we will get recombinant type also. Okay.
Yes, sir.
Now we will move to the statistical analysis. So this today's this information, or whichever I have tell you, this linkage and coupling phase, repulsion phase, and complete linkage and part incomplete linkage will be useful in next class, in upcoming class. Now we will move to the statistical analysis of segregation and linkage. So we will first consider single factor segregation. What is the meaning of single factor segregation? Can anybody tell me?
Only for one character,
Only one character, like?
only plant height or a pot color or pot shape, only one.
So we are considering, we will consider monohybrid cross. So the single factor is like capital A, and small a, small a. This is our parental type. So what is the meaning here? Statistical analysis. Why we are need this statistical analysis of this segregation? Tell me. So this is our parents are there, and in F1 we will get capital A small a. and after that in F2, or this will produce two type of gametes, that is capital A, small a. So they are segregating as per the law of segregation. We can say that the gametes are segregating, or genes are segregating in equal proportion, that is 1:1. Okay, now we have to test this ratio statistically. Is this, suppose my or null hypothesis is that segregating ratio, or we can say the gametes is having 1:1 ratio, but alternate hypothesis is this is not, there is some significant difference in that particular ratio. Okay, so this we have to test. Now uh, I will tell different tests are there, test of significance are there. How what type of test of significance are there?
T Z, T test, F test,
Yes, and
Y test, and Z test.
T, Z,
Chi square.
F, chi-square, and all. So these tests will be used for testing this ratio, that they are significantly different or they are in, this is our expected ratio. See, this is our expected ratio, 1:1, but we will see observed ratio, and on the basis of this expected ratio and observed ratio, we will check that we will use the test like chi-square or
Square.
T or Z.
Chi square test.
Chi-square, exactly. Now what is the formula of chi-square?
Summation of observed frequency minus expected frequency का whole square is divided by expected frequency.
That is observed minus expected
का
whole
whole
square.
square is divided by expected.
Okay, and what will be the degree of freedom?
N minus 2.
N
N
minus 2.
minus 1,
It,
1.
it will be n. I'm writing k, then it will be k minus 1. Okay. So and the property of chi-square is that the sum of observed frequency I is equal to 1 to k oi will be equal to the sum of expected frequency. Okay.
Sir, repeat please.
This is the property of chi-square, that sum of observed frequency will be equals to the sum of expected frequency. This is the property of chi-square, that observed frequency is will be equal to our expected frequency. Okay. Now suppose I want to check this 1:1 ratio. 1:1 ratio. So my this will be, suppose, so I'm writing, suppose this is my observed frequencies A1, A2, and type of gamete will be A, small a, and expected frequency will be, suppose, and this is total A1 plus A2 is equal to N. So expected frequency will be ny2 and ny2. Okay. So this will be ny2 and ny2, and after that we will calculate chi-square, and what will be the degree of freedom? It will be 1 for each gamete. Then it will be a1 minus a2 whole square divided by n. You just check it by using this formula. Okay, I am not going in the detail because this your genetics syllabus is too lengthy. Okay, so I'll not go in the detail. Then this will be chi square 1 a1 minus a2 whole square upon n. You just check it. Similarly, if the ratio is 3 is to 1, if you want to check the ratio that 3 is to 1 is the ratio, then our observed frequency will be same a1 a2 and expected n1 by n1 by 2 n by 2 and by 2. Then our chi square will be a1 minus 3 a2 divided by n, and this will be whole square. Okay, now I will tell one generalized formula for this. So the generalized formula will be chi square, that is will be 1 degree of freedom a1 minus l a2 square divided by n. Sorry, l n. So this will be general formula. So different type of ratios are there. Different type of ratios are there. So suppose that is of gametes, suppose back cross. So somebody asked that what will be the chi square back cross. I make a table in new page. Back cross. So this ratio will be, this is our observed, and this ratio is 1 is to 1. Then the chi square with 1 degree of freedom, that will be a1 minus a2. So the ratio I am writing l is to 1. Okay, so l is to 1, I'll write l here in back cross, l is equal to 1. Okay, so a1 minus a2 square upon n. So a1 minus a2 square upon n will be the chi square 1. Similarly, in f2 the ratio is 3 is to 1. Then l is what? L is 3. So chi square 1 will be a1 minus 3 a2 upon 3n. Now, in case of I am in case of if the ratio is 15 is to 1. So different conditions are there that will be they will mention the condition and they will give the ratio. So if the ratio is 15 is to 1, so L is what? 15. So this chi square will be a1 minus 15 a2 whole square divided by 15n. Now, if the ratio is 9 is to 7, so these are the different conditions of inheritance. So this 9 is to 7, then what will be the L? What will be the L?
9.
How come 9?
9 by 7.
9 by 7, because I am taking L is to 1 condition. So I will make this will take this side. So 9 by 7 is to 1 will be there. So chi square will be, so this is confusing. 9 is to 7 is confusing ratio. a1 minus 9 by 7 a2 whole square divided by 9 by 7 n. Okay, now if the ratio is 13 is to 3, so 13 is to 3, it will be 13 by 3 L. So chi square will be a1 minus 13 by 3 a2 whole square 13 by 3 n. So directly in the exam they can ask that what will be the chi square in case of back cross, in case of f2 in case of f2 generation, and if the ratio is 15 is to 1, if the ratio is 9 is to 7, is if the ratio is 13 is to 7, 13 is to 3. So this is the general formula of this chi square a1 minus l a2 whole square upon ln. Okay.
Sir,
Yes.
सर जो आपने जनरलाइज्ड फॉर्मूला लिखा है उससे ऊपर जो 3:1 का जो रेशियो है उसमें डिनोमिनेटर में 3n नहीं है, सिर्फ n है, तो वो सिर्फ n ही होगा।
कर दिया मैंने 3.
ठीक है सर, ओके।
Okay, so this is generalized formula that chi square that will 1 degree with 1 degree of freedom, it will be this generalized. Remember this generalized formula so that you can make any of the formula of any ratio. Okay. Just a minute. Now if the ratio is 1:2:1, if the ratio is 1:2:1, that if it is in question that when we have more than two classes, say three, in with single factor in F2 generation without dominance, I'm writing the statement here. When we have more than two classes, say three for example, for a single factor, and in F2 generation without dominance, so in there will be incomplete dominance. So the incomplete dominance, what is the ratio? That is 1:2:1. So this is our expected ratio. So see, I am writing capital A, small a, small a, small a. That is our expected ratio 1:2:1. So I can, if I write in this is observed A1, A2, A3, and A1 plus A2 plus A3 will be our n. Now, and our expected will be expected, this will be c 1 2 1. So this will be n by 4, this will be n by 4, and this will be 2n by 4, that is n by 2. Okay, so here we will get chi square with how many degree of freedom? 2 degree of freedom. K minus 1 or n minus 1, if I write, this will be a1 minus a2 whole square plus a1 minus a3 whole square plus a2 minus a3 whole square plus a1 minus a2 plus a3 whole square. This will not whole square, individual square divided by n. So how you will calculate this chi square? कोई बता सकता है मुझे कैसे हम इस फॉर्मूला को ड्राइव करेंगे? हाउ वी विल ड्राइव दिस फॉर्मूला? Basically, what was the formula of chi square? That is summation oi minus ei whole square divided by summation of ei, isn't it?
Yes, sir.
or or we can sorry, this whole, this summation will be there. So oi minus ei. So if I write this here, this is our observed frequencies, observed, and this is expected. So observed is what? A1, A2, A3, and expected is what? Ny4, Ny2, Ny4. The ratio will be 1:2:1. So oi minus ei, we will do a1 minus ny4, then a2 minus ny2, then a3 minus ny4. Then we will do square oi minus ei. So we will do a1 minus ny4 square, then a2 minus ny2 square, a3 minus ny4 square, then We will do OI minus EI square divided by EI. So EI is what? Expected frequencies. So expected frequency for first class is NY4. So A1 minus NY4 whole square divided by NY4. Okay. And then we will add all the three. Then we will take the sum of all these three. Then we will get this. So this is the derivation, or this is the theory behind the formula. So you have to remember directly that in case of incomplete dominance, that is 1 is to 2 is to 1, then we will get this chi square. Okay. Okay, any doubt in this? So I will suggest that you just purchase the book of Prem Narayan, so that you can get it. Statistical Genetics by Prem Narayan. It is very important book for this type of uh, this Mendelian genetics and linkage and all. Okay, so today I will stop here. I will share this PDF to you, and you just refer the book or notes and all. Okay, thank you.
Thank you, sir.
Okay.
चल बस